So, welcome to the new video. Today we are going to discuss about the motion in one dimension. So that is acceleration in one dimension. In our last lab, we have discussed about the velocity versus time graph and position versus time graph, right? So today we are going to add new graph here, that is acceleration versus time graph. Okay. So acceleration is defined as the rate of change in velocity. So if the object is speeding up or object is slowing down, there is the acceleration. If the object is speeding up, there is the positive acceleration. And if the object is slowing down, there is negative acceleration. So the negative acceleration is sometimes called as deceleration also. So acceleration is a vector quantity that has both magnitude and direction. Okay. So in this lab, we are going to discuss about the position versus time graph, velocity versus time graph, and acceleration versus time graph. I have written something right here. So this part is already discussed in our last lab. So when the displacement increases, velocity is positive. When displacement decreases, velocity is negative. And when displacement remains constant over the time, then velocity is zero. Similarly, in this lab today, we are going to discuss about these things. So when the velocity increases, acceleration is positive. When velocity decreases over the time, acceleration is negative. And when the velocity remains constant with respect to time, acceleration is zero. So keep in mind with this fact. So let's start with very simple case. In this lab also, we are also going to use the same motion detector. Okay, so this is our motion detector. Okay, and I'm going towards the motion detector and also away from the motion detector. If I'm going towards the motion detector, or if I am going away from the motion detector, I can draw the different graphs based on my position and motion. Okay, so let's suppose the very simple case. I am going towards the motion detector with constant velocity. Sorry, I am going away from the motion detector with constant velocity. My position is increasing with respect to time, and this is going linearly. Okay. So what about the slope of this line? The slope of this line is positive and also constant. Okay, because it is the straight line. So how can you find out the slope? You can find out slope by simply taking the ratio. Ratio is rise. This is your rise, and this is your run. Rise over run gives the slope of this line. Okay, so slope of this line is rise over run. So let's suppose rise is 12 meter and run is 3 seconds. Okay, so 12 meter divided by 3 seconds. So rise over run will be simply 4 meter per second. Okay, so you see meter per second, that is the velocity. Okay, from the slope of this position versus time graph, you got the velocity. Okay, and the velocity is positive and constant. That means you can simply draw a straight line that is positive and the constant. Okay, so what about this intercept? This intercept is 4 meter per second. Okay, so you got 4 meter per second. This is your intercept. Okay, and what about the acceleration versus time graph? Now forget about this graph. Now look at this graph. This is the velocity versus time graph. If you are going to find out the acceleration, acceleration is simply the slope of this line. What is the slope of this horizontal line? Always zero, right? So the slope is zero, that means the acceleration is zero in this case. Okay? So you can simply draw this line. Okay? This is for the acceleration versus time graph. Now let's consider another case. Okay, so now let's consider another case. I am stationary. I am not going towards the detector. I am not moving away from the detector. I remain stationary. And what is the nature of the line you see on the screen? It will be simply a straight line that is constant, right? So your position is not changing with respect to time. Now, what about the velocity versus time graph? You just look at the slope of this line. The slope of this line is 0. That's why the velocity versus time graph will be simply this line. And the acceleration versus time graph will be also 0, because acceleration is the slope of the velocity versus time graph, and that is still 0. Okay? So this is a very simple case. Now let's consider another case. Now I am moving towards the motion detector with my constant speed or constant velocity. Okay? If I am going towards the motion detector with constant velocity, the position versus time graph is decreasing over the time. It is going down linearly. Okay? So what about the slope of this line? The slope of this line, it will be negative and constant. Okay? So what about the velocity versus time graph now? How can you draw? So you can just look at the slope of this line, that is negative and constant. Okay? So this will be negative and constant. Okay? So you can still find out the slope of this line and find out this intercept. The same process as we discussed before. And what about the acceleration versus time graph? It is simply a flat horizontal line. The acceleration is 0. Okay? So acceleration versus time graph will be simply a 0. So this is the third case. So I'm going to discuss about another situation now. Now another situation is I'm going away from the motion detector with my increasing speed. Okay, I'm moving away from the motion detector with increasing speed. So my graph is like, okay, so the graph is increasingly. Okay, so you are going to find out the slope of this line at a different portion. So if you consider this portion, this is simply a flat horizontal line. Okay, so this portion has the slope 0. Okay, what about this part? In this part, somewhere right here, the slope could be positive 1. Okay, and it could change to another value at the different part. Okay, so in this portion, slope is 0. In this portion, slope is 1. So your slope is increasing from 0 to 1. Okay, so you can draw the velocity versus time graph just looking at this slope of these two points. Okay, so this slope is 0. Right here, the slope is 0, and your slope goes to 1, and it may increase to another value as well. Okay, so your slope is increasing, and the slope is positive. Okay, now look at the velocity versus time graph. The velocity is increasing, and it is positive as well. Okay, so what does that mean? If you are going to look at the acceleration versus time graph, your acceleration is positive and increasing. So your acceleration is positive and constant, okay? Because the slope is positive and constant, okay? So it will be simply this line, okay? So this is another situation. Now let's consider another case. Now let's consider another case. Now you are throwing a ball vertically upward, that is projectile motion. So let's consider projectile motion. I'm just considering only this projectile motion, this region. You are throwing a ball up to the vertical height. Okay. So your graph is increasing decreasingly. Okay. The position versus time graph. Now what about the velocity versus time graph? You can just look at the position versus time graph and find out the slope at different portion of the graph, just as we did before. So this portion has the slope 1 somewhere here, because somewhere here it is making 45 degrees. Okay, so it has the slope 1, and this is the horizontal and flat region that has the slope 0. Okay, so your slope is decreasing from 1 to 0. Okay, so if you go to the velocity versus time graph, your slope will change from 1 to 0. Okay? And what about the acceleration versus time graph? Okay? So if you look at the acceleration versus time graph, you can just find out the slope of this line, this horizontal line. It is going down, it is decreasing, so slope is negative, and slope is also constant. So where the acceleration versus time graph lies, it lies in the negative axis because its slope is negative and constant. So it will be simply a horizontal line that lies in the negative axis. Okay? So this is one situation. Now let's consider the case when you threw a ball vertically downward from a certain height. That is still the projectile motion. Okay? So you are throwing a ball vertically downward. Okay? Now, what about the velocity versus time graph? How can you draw the velocity versus time graph? So you still look at the slope of this curve. Okay? So in this region, this is the flat horizontal line that has the slope 0. Okay? And this portion has the slope -1 because it is going down, and somewhere there is 45 degree in the negative direction. Okay? So somewhere in this portion, your slope will be -1. Okay? So your slope goes from 0 to -1. So so if you draw the velocity versus time graph, your graph will go from 0 to -1. So let's suppose -1 is right here. So it goes like 0 to -1. Okay? So what about the acceleration versus time graph? Now look at here. Forget about this graph. Look at the velocity versus time graph. Now you can just find out the slope of this line. The slope of this line is negative because it is going from 0 to -1. It is decreasing and it is still negative. Okay? So if you find out the slope of this line, the slope is negative and constant. So acceleration versus time graph will be negative and constant. Okay? Now let's consider another situation. This is our last situation. So I'm going to discuss about another situation now. So another situation is your position is decreasingly over the time. Okay? So your position is going decreasingly. So what about the velocity versus time graph? Now look at the slope. Okay? So this portion of the graph has the negative slope, and let's suppose somewhere the slope is -1. Okay? So it looks like somewhere there is -1 slope, and this flat portion has the slope 0. Okay? So your slope goes from -1 to 0. Okay? So your slope goes from -1 to 0. In the velocity versus time graph, you are going to plot that slope. So the slope is -1 to 0. Okay? So this is the plot of the velocity versus time graph. What about the acceleration versus time graph? So look at the velocity versus time graph. Your velocity is increasing from -1 to 0. Okay? The slope is increasing in the negative direction, but still it is positive and it is constant. Okay? So if you draw the acceleration versus time graph, it will be positive and constant. Okay? This is how you draw the acceleration versus time graph. Okay, so I have discussed as far all the possible situation. Okay? So I think this material will be useful for your class next week. And I'm not going to summarize all the results I have discussed so far, but look at this velocity versus time graph and acceleration versus time graph only. So in this situation, your velocity is increasing from -1 to 0. At some point, at some instant of time, the velocity goes to 0, but there is still constant acceleration, right? So acceleration there could be the acceleration even when you are at rest. Okay? So this is the realistic situation. For example, when you threw a ball vertically upward, at some point in the space, your ball will come to rest, okay, where the velocity is 0, but there is still the acceleration. The ball is accelerating downward with acceleration due to gravity, that is 9.8 meter per second squared. Okay, so this type of so we are going to discuss about this type of logical questions in the class based on velocity versus time graph and acceleration versus time graph as well. So in our lab, we are still taking the motion detector, and we will be accelerating towards or away from the motion detector, and we find out the different type of the graph, and we'll interpret our graphical nature of those things. Thank you for your attention. Have a good time. Thank you.